Problem 731. For the following, calculate the new temperature in degrees Celsius when the pressure is changed with your number of moles and volume staying constant. A sample of xenon gas at 19 degrees Celsius and 855 millimeters of mercury is cooled to give a pressure of 615 millimeters of mercury. All right, the great thing about gas problems, I've always said, is that they basically solve themselves. What do I mean by that? Well, let's go through and label what they've given us. That's the first step whenever you work a gas problem. So you've got a temperature for the first time equal to 19 degrees Celsius? Celsius? What rude, crude, abominable individual would dare sully our eyesight with a Celsius scale? I can't believe I even had to write it. Oh, the horror, because everybody knows and remembers that Celsius is dead to us. Celsius is God's plague upon humanity, and we must convert it to Kelvin as quickly as possible. All right, breathing much easier now that that's done. All right, we've got it into Kelvin, because Kelvin's the only correct temperature scale you can use with gas laws. So that's the first temperature they give us. Then they tell us that the related pressure is 855 millimeters of mercury. They then tell us that we have a second pressure of 615 millimeters of mercury. Well, we have two pressures and one temperature. And whenever you have two of anything, you have to use your combined gas law. P1, V1, N1, T1 equals P2, V2, N2, T2. I know to use this law because I have two pressures. Right away in the problem, they tell us that our number of moles isn't changing and that our volume is constant as well. They tell us that up here. So I can cross out my volume and my number of moles. And when I do so, that gives me P1, T1 equals P2, T2. And now it's plug and chug time. Make sure your pairings are correct. Because we are using the combined gas law and 0 is in the correct place, we can work it in Torr here. So we've got 292, 855 to 292 equals 615 over the T2 we're wanting to solve for. Right, in this problem, they're asking us to solve for the second temperature. One thing I've noticed that causes people issues is the fact that the temperature down here is the variable you're solving for is on the bottom. Remember, the easiest way to solve one of these is to do crisscross, right? Whatever's on the bottom, you're going to bring up and multiply it by on both sides. So I have to get T2 on top, not as a reciprocal, so I'm going to multiply both sides by T2. Then I have 290. Well, we'll just do it that way. All right. So now I write what I've got. I've got T2 times 855 millimeters of mercury times 292 Kelvin equals 615 millimeters of mercury. I need to get T2 by itself now that I've gotten it up from the bottom. So I'm going to multiply by the reciprocal here. So that our T2 is by itself. And oops, wrong tool there. right? 292, 855, that crosses out. And that leaves us with T2 equal to that term. So I grab my calculator, I punch it all in. And that gives us 210 10.0 Kelvin. They want our answer in Celsius, so one last cutesy finishing step. Minus 273 to get it back into Celsius. And that gives us 62.96 or 63 degrees Celsius. So that's your answer to part A. All right, let's take a look at part B. Part B is the exact same thing, except they have some fun with units. So let's take a look at this fun with units that they're having on us here. We read the problem, we label our units. First of all, they gave us a pressure, 0.920 atm, which is fine, good, and easy to use if we want to. And they give us a temperature in Satan's units. Once again, they have been so cruel and so mean as to sully our eyes with the abomination that is the Celsius scale. We must wipe its existence from our eyesight and convert it right away to Kelvin. They then give you a second pressure. For the first time, we do have a problem with the end. We're wanting to solve for our second temperature in Celsius. For the first time, we do have a little bit of a problem here, and that problem comes from the fact that we have different units of pressure. It doesn't matter which way you go. If you want to convert ATM to torr to ATM, I'm going to convert torr to ATM. 760 torr, 1 ATM, and that's going to give me 1.77 6 ATM. Now I have two pressures, so I know I'm going to use my combined gas law. P1 V1 N1 T1 equals P2 V2, because when I have two of anything, I use my combined gas law. They tell me in the problem that my volume is constant, so it gets crossed out, and that my number of moles is constant, leaving me with P1 T1 equals P2 T2. So now we become plug and chug. And where do they tell me my pressure and volume was? Where did they tell me that my volume and my number of moles was constant? Up in that blue box there. All right, so now I'm going to plug and chug. So I have 0.920 atm over 259 Kelvin equals 1.776 atm over T2. You can't solve for a variable that's on the bottom. So the first thing you have to do is get that variable up to the top. So you're going to multiply both sides by that T2 so that it's not on the bottom. Right? Now we've crossed out the T2. So we've got T2 times 0.920 atm Now I need to get my T2 by itself. So I'm going to multiply by the reciprocal of the fraction I'm multiplying by. I'm dividing by 259, so I need to multiply by it. Oops. I'm multiplying by 0.29, so I need to divide by it to get rid of it. I have to do the same thing to both sides. 259 times 0.920. That cancels out. That cancels out. So now I'm left with T2 by itself. Right, so now I have T2 equals 1.776 ATM times 259 Kelvin divided by 0.920 ATM equals calculator work. Ooh, sweet. It's a thing of beauty, I tell you. 500 Kelvin. The people that wrote this are troglodytes and want your answer in Celsius. So you're going to have to go ahead and subtract that 273 to get back to the Celsius scale. And that's going to be 227 degrees Celsius. Let's take a look at problem 755. A 35-gram sample of nitrogen has a volume of 60 liters and a pressure of 625 millimeters mercury. What is the temperature in kelvins and degrees Celsius of the gas? All right, I have no idea how I'm going to work this problem as I initially read it. The great thing about gas problems is you really don't have to. You just have to read and label what you come to. So let's see. First thing they do is they give me a mass of nitrogen. So they tell me I have 35 grams of nitrogen. They tell me I have a volume of 60 liters, and I've got a pressure of 625 millimeters of mercury. And they're wanting me to solve for a temperature. Well, do I have two of anything? No, I don't have two of anything. So if you don't have two of anything, you have to use PivNert. So I am very happy because I get to use PivNert, my favorite all-time equation. Well, I know my gas constant, memorize that. I'm wanting to solve for my temperature, so I'm good there. They gave me a pressure and they gave me a volume. But I need a number of moles in order to work this problem. Well, where can I get a number of moles? They gave me grams. And you can do grams to moles in your sleep at this point. So let's convert to 35 grams of nitrogen to moles of nitrogen. So I'm going to need to go to my periodic table. And 14 times 2, I get 28.061 grams of nitrogen per 1 mole of nitrogen. So I'm working with a strange calculator today. So I'm moving a little slow. 1.249 moles of nitrogen. So now I have moles. One other thing I need to do before I can use PivNert is remember your pressure in order to use PivNert has to be in ATMs because we've only memorized one value of that gas constant. So let's convert millimeters of mercury into ATM. And that's going to give me 0.8224 ATM. So now I have what I need to plug and chug. So I've got a pressure of 0.8224 ATM times a volume of 60 liters equals 1.249 moles. That's 9. 9, and there's a 1 there, right? 1 times our gas constant, 0.0821 liters, moles, ATM, whoops. Liters, ATMs, moles, Kelvin, times our temperature. Now it's algebra. Get temperature by itself. That's 0.8224 ATM times 60.0 liters divided by 1.249 moles times 0.0821 liters, ATMs, moles, Kelvin. Divide by, and that gives me a temperature of 481 Kelvin. And this is where they're kind of evil, because this is the answer to part B, yes? You actually solve for the answer in part A separate, because your Piv nerd always gives you in kelvins first. So to get Celsius, you're going to subtract 2. Oh, what in the world? That's not what I wanted to do, obviously. All right, try again. $73 Kelvin. And that gives you 208 Celsius and 481 Kelvin. That's it. Beat